I am taking one problem from jail, and also it is from set. Just integral modulus of z minus 2 is equal to 2 z into dz divided by z power 4 minus 1 is equal to. We have options here. First option 1, second option 2, third option I pi by 2, and fourth option pi by 2. These are the 4 options we have. Okay. Now, first we have to calculate the singularities. For singularities, the denominator, I am writing for singularities, the denominator will be 0. Z power 4 minus 1 is equal to 0 means this is in the form of z square minus 1 into z square plus 1 is equal to 0. From this we can write z is equal to plus or minus 1 plus or minus I. Okay. Here the circle is center at this is origin, real axis, and imaginary axis, and it is the point I am taking 1. This is the point 2. Yeah, this is point 2, and we can take we can extend this. This is the point 3 and point 4. Okay, centered at 2 with the radius is 2. That means this is the circle. This is the circle. Here z is equal to 1 is inside the circle. So since z is equal to 1 is a simple pole, it is a simple pole inside the circle, modulus of z minus 2 is equal to 2. Okay. So we can calculate the residue at the point z is equal to 1. So residue of the function f of z at z is equal to 1 is equal to, it is a simple pole. So limit z tends to 1, z minus 1 into f of z. That is equal to limit z tends to 1, z minus 1 as this. F of z is, numerator is z, denominator is z power 4 minus 1. So we can write z divided by z power 4 minus 1 can be written as z square minus 1 into z square plus 1. Okay. So here 1 z minus 1, here this can be written as z minus 1 into z plus 1. Here z minus 1 into z plus 1. This z minus 1 will be cancelled, and apply z is equal to 1 here in this. So we get 1 by 1 plus 1, 2. This is 2. This is equal to 1 by 4. This is the residue of the function f of z. But we have to calculate the integral value. Therefore, integral over c f of z dz is equal to 2 pi I into residue of the function. That is 1 by 4. So that is equal to pi I by 2. So pi I by 2 is the integral value. That is third option is the right option. Okay. Third option is the right option. Now I am taking another problem from jail. For f of z is equal to 1 divided by z minus z cube, the point z is equal to infinity is. We have options here. First option, pole second option, a regular point, and third option, a zero, and fourth option, here a pole. First option is a pole, and fourth option is a fixed point. A fixed point. Okay, we have four options. First, for poles, we can equate the denominator as 0. For poles or for singularities, the denominator z minus z cube is equal to 0. We can take z common here. 1 minus z square is equal to 0. Z is equal to 0. One pole, z is equal to plus or minus. Or simply I am writing z equal to 0 comma plus or minus 1 are the poles. So z is equal to pole means, z is equal to, it is a pole means, z is equal to infinity is a 0. Is a 0. So third option is the right option. Okay. Third option is the right option. Now I am taking another problem from Jl. It is also from Jl. The set of singularities. It is Jl question. The set of singularities of f of z is equal to 1 divided by z into z square plus 4. Z into z square plus 4 is. We have options here. Singleton set to 0 comma 2. Second option 0 comma 2i comma minus 2i, and third option 2i comma minus 2i, and fourth option singleton set to 0. These are the four options we have. Okay. For singularities, we have to equate the denominator as 0. Okay, or poles. For singularities, we should equate the denominator z into z square plus 4 is equal to 0. That is, z is equal to 0 and plus or minus 2i. These are the singularities. Okay, we can write the second option is the right option. Set of singularities means 0, minus 2i, and plus 2i. These are the singularities of the function. Okay. Now I am taking another problem from Jl. Is also from Jl. Residue of I divided by z minus z square. I divided by z minus z square. At z is equal to 1 is equal to. We have options here. First option 1. Second option minus 1 by 2. Third option 1 by 2. And the fourth option minus 1. These are the options. Okay. Already z is equal to 1 అని ఇచ్చేసాడండి. Z is equal to 1 simple pole of order something ఏదైనా ఉందా మనం చెక్ చేసుకోవాలి. For this, first of all, we can equate the singularities. Here the singularities z minus z square is equal to 0. So when z minus z square is equal to 0 means z of 1 minus z is equal to 0. Z is equal to 0 comma 1. So z is equal to 1 is a simple pole. Is a simple pole. We know that. So simple pole means we can calculate residue at z is equal to 1. That is z is equal to 1 is a simple pole. So residue of the function I by z minus z square is equal, z is equal to 1 is equal to, that is limit z tends to 1, z minus 1 into function f of z is, that is I by, we can take z into 1 minus z as, okay, z minus z square can be written as z into 1 minus z. So here z minus 1, 1 minus z cancel అయితే minus 1 ఉంటుంది. Minus 1 into I means minus I. Now apply z is equal to 1 here. So we get to minus I. Actually ఆప్షన్ లో మైనస్ I అనేది లేదండి. I think okay. is ఇక్కడ I ఉండకూడదు అనుకుంటా. I think. Okay. I don't know. It is minus I. Okay. Option లో ఏమన్నా రాంగ్ ఉండొచ్చు. We will discuss. Okay. Now I'm taking another problem. Residue of the function, I'm taking the simply integral value is DL question 1 by 2 pi I 1 by 2 pi I integral over C e to the power of 2z by 3 into e to the power of 2z divided by z minus 1 whole to the power of 4 into dz is equal. Okay. Now, I'm sorry, it is a jail question. We can just calculate the integral value. For this, we have to calculate the residues. Okay, I'm giving the options. First option is 0. Second option is 2 e to the power of minus 2. Third option is I think it is not clear. 8 pi I by 3 e to the power of 2, and the fourth option 4 e to the power of 2. Okay, so we can see the options clearly. We can see the solution. For singularities, we have to calculate the we can equate the denominator as 0. So z is equal to 1 is a pole of order, is a pole of order m is equal to 4. Okay, z is equal to 4 is a pole of order m equal to 4 means we can calculate the residue, that is residue of the function f of z. We are writing at z is equal to 1 is equal to limit z tends to 1 d to the power of 1 by, first we can write 1 by 4 minus 1 factorial d to the power of m minus 1. M minus 1 means 4 minus 1, that is d cube divided by dz cube into z minus 1 whole to the power of 4 into the function f of z. The function f of z. So this is equal to limit z tends to 1. This is 1 by 3 factorial, third derivative. D cube by dz cube of z minus 1 whole to the power of 4 into f of z is, here we are given 3 into e to the power of 2z divided by z minus 1 whole to the power of 4 will be cancelled. So we can equate the 1 by 3 factorial is 6, limit z tends to 1. Here 3 is there, so we can write 3 into one time in differentiation. So we get d square by dz square of 2 into e to the power of 2z. 2, 3, 6 will be cancelled. Okay. So this is equal to limit z tends to 1. Again differentiate this. With respect to z here, d by dz. So 2 into e to the power of 2z. Okay. So this is equal to, again differentiate with respect to z, we get to 4 into e to the power of 2z. So apply z is equal to 1. When z is equal to 1, we can get to 4 into e to the power of 2. 4 into e to the power of 2. Okay. So fourth option is the right option. ఇక్కడ మనకు కరువు అనేది మెన్షన్ చేయలేదండి. ఓకే, సి ఇస్ ద కరువు అన్నాడు. ఓకే, దట్ మీన్స్ జెడ్ ఈస్ ఈక్వల్ టు 1 ఇన్సైడ్ ద కరువు అన్నట్టే. వాడు ఇటు రెసిడ్యూ ఫైండ్ అవుట్ చేసుకోవాలి కాబట్టి. ఓకే, కాబట్టి ఇక్కడ మనం ఇన్సైడ్ గానే తీసుకోవాలి. జెడ్ ఈస్ ఈక్వల్ టు 1. సో అక్కడ తీసుకుంటేనే మనకు రెసిడ్యూ క్యాలిక్యులేట్ అవుతుంది. ఓకే, సో ఐఎమ్ టేకింగ్ అనదర్ ప్రాబ్లం. And it is also from JL. For f of z is equal to e to the power of 1 by z, z is equal to 0 is a simple question. First option, a removable singularity. A removable singularity. And second question, a pole of order 1. A pole of order 1. And third option, an essential singularity. An essential singularity. And third option, fourth option, a pole of order 2. A pole of order 2. Okay, these are the 4 options we have. Now, just we have to see the z equal to 0 is what about z equal to 0? First of all, we have to expand the function. That is, f of z is equal to e to the power of 1 by z. We can write the expansion 1 plus 1 by z by 1 factorial plus 1 by z whole square by 2 factorial. I'm writing one more term here, 1 by z whole cube by 3 factorial plus and so. This is the expansion. So we can write here 1 plus 1 by z plus 1 by 2z square plus 1 by 6z cube plus and so. Okay, but here clearly we can observe z equal to 0 is a singular point, pole of order. This is the, clearly it is the principal part. And this principal part as infinite many terms. The Lorentz series as the principal part has an infinite many terms, then the point, therefore the point z equal to 0 is an essential singular point. Is an essential singular point. Only 2 terms ఉన్నాయి అనుకోండి. 1 plus 1 by z 1 by 2z square ఉంటే అప్పుడు z ఈక్వల్ టు 0 ఈజ్ ఎ పోల్ ఆఫ్ ఆర్డర్ 2 అనేవాళ్ళం. 1/2 నాట్ ఈక్వల్ టు 0 కాబట్టి. ఒకవేళ ఓన్లీ 1 టర్మ్ ఉందనుకోండి, 1 + 1/z, 1 ఈజ్ నాట్ ఈక్వల్ టు 0 కాబట్టి z ఈక్వల్ టు 0 ఈజ్ ఎ పోల్ ఆఫ్ ఆర్డర్ 1. దట్ ఈస్ సింపుల్ పోల్ అనేవాళ్ళు. రిమూవబుల్ సింగులారిటీ ఎప్పుడు అంటాం? ప్రిన్సిపల్ పార్ట్ does not exist. There is no principal part in the expansion of f of z. So in this case, the z equal to 0 is called an essential singular point. Okay, third option is the right option. Okay. Now I am taking another problem. The residue of it is a set other state set problem. The residue of f of z is equal to 1/z square plus 1 whole square. At z is equal to z square plus 1 at z is equal to I equals. We have first option I/4. Second option minus I/4. Third option I/2. Fourth option minus I/2. These are the 4 options we have. First of all, we have to see the singularities. What are the singularities we have here? Okay. So for the singularities, the denominator z square plus 1 whole square is 0. For singularities, the denominator z square plus 1 whole square is equal to 0. That is z square plus 1 is equal to 0 twice. 2 times it is 0. Okay. So z square is plus 1 equal to 0 means z is equal to plus or minus I twice. Plus or minus I twice means z is equal to plus or minus I comma plus or minus I. So z is equal to I దగ్గర calculate చేయాలి residue. So z equal to I is a pole of order m is equal to 2 order. Okay. So at this point we have to calculate the residue. So therefore residue of the function f of z at z is equal to I, that is limit z tends to I 1/2 minus 1 factorial, that is 1 factorial d by dz of z minus I into f of z. F of z is 1/z square plus 1 whole square. So this is equal to limit z tends to I d by dz of z minus I into, actually it is z square plus 1 into z square plus 1. Okay. So ఇక్కడ మనకు ఇక్కడ స్క్వేర్ వస్తుంది కదా, రైట్. దిస్ ఈస్ లిమిట్ z tends to I d by dz of z minus I whole square into, we can write here z minus I into z plus I. Okay, same term అండి, దీనికి whole square రాస్తున్నా, దీనికి whole square రాస్తున్నా. Z minus I whole square will be cancelled. So this is equal to limit z tends to I d by dz of 1/z plus I whole square. So differentiate this with respect to z. That is equal to limit z tends to I is I. So minus 1 by minus 2 by z plus I whole square. Okay. So this is equal to minus 2 divided by I plus I, 2I whole square. That is equal to minus 2 divided by 4I square. I square minus will be cancelled. This is equal to 1 by 2. Okay. So by 2 వస్తుంది కదా 1 by 2 means ఆప్షన్ లో 1 by 2 లేదు కదండి. 1 second. చేసాము. Z is equal to one second. Here I 2 times.
Sir, differentiation once you check.
Sir, minus 2 by z plus I whole cube.
Minus 2 by z plus I వస్తుంది సార్ అంతే.
Z plus I whole cube, sir. Differentiation.
Minus right. Yes. Here we have.
B, sir.
Yeah. This one is one. So here we can write minus 2 divided by 2I whole cube. That is equal to minus 2 divided by 8I cube. I cube means minus I. So this is equal to minus 2, 4. 1 by I means this 4 minus I by 4. So minus I by 4 is the, second option is the right option. Okay. Now I am taking another problem. The value of the integral is also set to problem. The value of the integral, integral over C z square plus 1 divided by z square minus 1 into dz, where C consists of the circle. C consists of the circle of unit radius with the center at z is equal to minus 1 is. It means okay, question that is only. So first option 0, second option pi I, third option 2 pi I, and the fourth option minus 2 pi. These are the 4 options we have. So we have to calculate the integral value, not residue. So the denominator for singularities, denominator z square minus 1 is equal to 0. Z is equal to plus or minus 1. So z is equal to minus 1 and plus 1 are simple poles. So we have to take the circle. C consists of the circle of unit radius with center at z is equal to -1. Means unit circle means modulus of z is equal to 1, center at -1. Then modulus of z plus 1 is equal to 1. Circle is this. Okay. So we can see the diagram. Origin. It is negative. Is 1. Radius is means we have like this. This is the same. So z is equal to -1 is inside the circle. So z is equal to -1 is a simple pole. Is a simple pole, and inside C. C means circle. This is a circle. Okay. So we can calculate residue at the point z is equal to -1. Okay. So therefore, first we are calculating residue of the function f of z at z is equal to -1. That is equal to, it is a simple pole, means limit z tends to -1, z plus 1 into f of z. So this is equal to limit z tends to -1, z plus 1 into f of z. The function f of z is z square plus 1 divided by z square minus 1. Okay. So this is equal to, we can write limit z tends to -1. Here it is z plus 1 into same term z square plus 1. Here z plus 1 into z minus 1. Okay. Here z plus 1 will be cancelled, and apply z equal to a -1 here. So the numerator 2, denominator also 2. This is equal to 1. Residue is
Sir, denominator -2, sir.
yeah, -1 -1. Okay, -2. So it is -1. Therefore, integral over C f of z dz is equal to, by definition of residue, that is equal to 2 pi I minus 1. So that is equal to minus 2 pi I. Okay. So fourth option is the right option. Okay. Next, I am taking another problem. The residue is also from set the residue of the function f of z is equal to z divided by z minus 1 into z minus 2 whole square. At the point z is equal to, at the point z is equal to 2 is. We have options here. First option 0, second option -1, third option 1, fourth option.
అద్వైత వాడు కూడా ఒక్కొక్కసారి ఈ టైంలో వంతాడు.
So we can calculate residue only at z equal to 2. Clearly we can observe the z equal to 2, since z is equal to 2 is a pole of order 2 and 2 times 0 అవుతుంది, is a pole of order m is equal to 2. Then a residue of the function f of z at z is equal to 2 is equal to 1 by 2 minus 1 factorial limit z tends to 2 d by d minus 1, d power 2 minus 1, that is d, by dz of z minus 2 whole square into f of z. I'm writing it. So this is your factorial. That is, this is 1. So limit z tends to 2. Here d by dz of z minus 2 whole square f of z. Here z by z minus 1 into z minus 2 whole square. So here z minus 2 whole square will be cancelled and apply z equal to 2 here. So numerator is 2, denominator is 1. So this is equal to 2. Option 4 is the right option. Option 2 and
D by dz is there.
Sir, derivative
Differentiation.
చేయాలి కదా సార్ ఆప్షన్ 2
okay,
రైట్.
okay. Yeah.
Option 3, sir.
Therefore, derivative is there. So we need to differentiate one time by using u by v formula. So limit z tends to 2. So here numerator denominator is u by v formula here, z minus 1 whole square of z minus 1 into 1 minus z into 1. So here plus z minus z will be cancelled. Numerator is z tends to 2, numerator is minus 1, denominator is z minus 1 whole square. That is equal to minus 1 divided by 1 square. That is equal to minus 1. So second option, I'm sorry. Second option is the system. Is the right option. Okay.
సార్ +1 కదా
Plus 1 and
అవును సార్
No, sir. -1 only.
z minus 1 ఉంది కదండి ఇక్కడ minus 1
-1 సార్ అబ్సల్యూట్లీ.
సార్
అబ్సల్యూట్లీ -1 సార్ రైట్ ఆన్సర్ సార్. ఓకే సార్.
okay, sir. Now I am taking another problem. It is also from set problem. The function f of z. I'm taking here. I'm taking next. It is also set. Of course, it is a GL problem also. The function f of z is equal to the function f of z is equal to numerator is z square minus 2z plus 3 divided by z minus 2 as. Okay, we have options here. First option, a pole of order 2, pole of order 2 at z is equal to 2. Second. And second option, essential singularity at z is equal to 2. Essential singularity at z is equal to 2. And third option, pole of order 1, pole of order 1 at z is equal to 2. At z is equal to 2. And fourth option, no singularity at all. No singularity. No singularities. A very simple question. Directly we can take the option at all. Actually, no singularity at all is చెక్ చేసుకోవచ్చు. ఇది కాదని ఫస్టే కొట్టేయచ్చు, ఎందుకంటే డినామినేటర్ లో టర్మ్ ఉంది కాబట్టి. ఫర్ సింగులారిటీస్ ది డినామినేటర్ is 0. Singularities denominator z minus 2 is 0. So z is equal to 2 is a pole. Therefore z is equal to 2 is a simple pole. Simple pole means pole of order 1. Pole of order 1 means pole of order 1. Third option is the right option. Pole of order 2 at z is equal to 2 is wrong. And essential singularity at z is equal to 2 is also okay. అంటే z minus 2 తర్వాత z minus 2 హోల్ స్క్వేర్ టర్మ్ ఉండాలి డినామినేటర్ లో z minus 2 హోల్ క్యూబ్ అంటే ఇన్ఫినైట్ నెంబర్ ఆఫ్ టర్మ్స్ ఉన్నప్పుడు ఎసెన్షియల్ సింగులారిటీ అంటాం. కానీ ఇక్కడ మనకు ఓన్లీ z minus 2 టర్మ్ తోటే స్టాప్ అయిపోతుంది కాబట్టి ప్రిన్సిపల్ పార్ట్ ఆగిపోతుంది కాబట్టి యూ కెన్ సీ ద we can talk about only pole. Here 1 times 0 means simple pole. Simple pole means order. I'm taking another problem. The function f of z, the function f of z is equal to 1 minus cos z by z square as. Okay. First option, pole of order 1 at z is equal to 0. First option, pole of order 1 at z is equal to 0. Second option, removable singularity at z is equal to 0. Removable singularity at z is equal to 0. Third option, essential singularity at z is equal to 0. Essential singularity at z is equal to 0. And the fourth option, no singularity at any point. No singularity at any point. Okay, no singularity at any point అనడానికి లేదు ఎందుకంటే డినామినేటర్ లో ఒక టర్మ్ ఉంది. You can calculate the
Option 3.
option 3. Okay, we'll see that. See,
Option 2, sir.
okay. First I am taking the function f of z is equal to, we can write 1 by z square of 1 minus cos z. Okay. So I am writing 1 minus cos z by z square. Okay, here z square is there. 1 by z square. Here, write the expansion of cos z. Cos is an even function. So the expansion of cos z is 1 minus z square by 2 factorial plus z power 4 by 4 factorial minus z power 6 by 6 factorial plus and so on. Okay. So here 1 will be cancelled. It is 1 by z square. First term, z square by 2 factorial. Second term, minus z power 4 by 4 factorial. And z power 6 by 6 factorial plus and so on. This is plus and this is minus. I'm multiplying here minus. That's why we are changing the signs. Okay. So now multiply with the 1 by z. So first term 1 by 2 factorial. Second term z square by 4 factorial. And z power 2 by 6 factorial minus and so on. Okay. Here this is a completely analytic part. This is completely an analytic part. At analytic part. And there is no z equal to 0 గురించే మాట్లాడుతున్నామండి. There is no principal part and has no principal part. Principal part at Z is equal to 0. Z is equal to 0, the function completely analytic function. So it has only the expansion of f of z has only analytic part. So the yes, and as no principal part lead means it is a removable singularity at z is equal to 0. Okay, so option 2 is the right option. Okay. Now I'm taking another problem. The function f of z is equal to the function f of z is equal to exponential of 1 by z as options are same here. First pole of order 1 at z equal to 0, pole of order 1 at z equal to 0. Second, removable singularity at z equal to 0. Removable singularity at z equal to 0. Okay, this problem is essential singularity. Cover chesavandi. Okay, I will go for another problem. E to the power of 1 by z and this. Okay, see another problem. Essential singularity వస్తుంది. It has an infinite many points in the principal part. That's why z equal to 0 is an essential singularity of the function f of z is equal to e to the power of 1 by z. E to the power of 1 by z is nothing but exponential of 1 by z. Okay. Now I'm taking another problem. Let's see the circle. Letter is a JL question. C is the circle. Circle. Modulus of Z is equal to 2. Positively oriented. Positively oriented. Then the value of the integral. Value of the integral over C 5z minus 2 divided by z into z minus 1 dz is. Okay, we have options here. I'm writing options here. 5 pi I. Second option 10 pi I. Third option 3 pi I. And fourth option 2 pi I. Okay, these are the options we have. First, you have to see the singularities. Denominator is 0. For singularities, denominator z into z minus 1 is equal to 0. So, z is equal to 0 comma 1. Z is equal to 0 comma. These are the simple poles, so we can draw the diagram here. Z is equal to, it is a modulus of z, means this 1, this 2. Radius is 2 means this is like this. This is the minus 1 and okay, minus 2. So z is equal to 0 and 1. Both are inside the circle. Okay. Therefore, or inside the circle modulus of z is equal to 2. We have to calculate the residue at z is equal to 0 as well as z equal to 1. First I am calculating. We can observe here z equal to 0 and z is equal to 1 are simple poles only. First I am calculating residue and the function, residue of the function at z is equal to 0 as limit z tends to 0, z minus 0 into f of z. F of z that is equal to limit z tends to 0, z into f of z is pi z minus 2 divided by pi z minus 1 divided by z into z minus 1. So here z will be cancelled. Now apply z equal to 0 here in this. So minus 2 divided by minus 1 is 2. Okay, now unchanged. Again calculate the residue of the function f of z at z is equal to 1 is equal to limit z tends to 1, z minus 1 into f of z. Because z is a simple pole. So we can use this formula, limit z tends to 1, z minus 1 as this. F of z is pi z minus 2 divided by z into z minus 1. Okay, z minus 1 kada? Yes. Now apply z equal to 1 here. As z tends to 1, we get 3 by 1, that is 3. Okay. So we can use sum of residues, that means Cauchy residue theorem. Therefore, integral over C f of z dz is equal to 2 pi I sum of residues. Sum of residues. Okay, ఇవన్నీ స్టెప్స్ మీరు చేయకూడదు. నేను క్లారిటీ మీరు ప్రిపేర్ అయ్యేటప్పుడు కష్టం అవుతుంది ఎలా రాశారనేది. మీరు ఐడియా పెట్టి ఫాస్ట్ గా వెళ్ళిపోవాలి. 2 pi I into residues, sum of residues. That is 2 pi I, 2 plus 3 is 5. It is 10 pi. This is the integral value of the given. Okay. Now I am taking another problem. Let C be the circle. Let C be the circle. Modulus of z is equal to 3. Then integral over C zq minus 3 divided by z minus 2 whole cube. Z minus 2 whole cube dz is equal to, we have options. Option 1 pi I, option 2 12 pi I, option 3 2 pi I, option 4 0. I'm taking singularities. For singularities, denominator z minus 2 whole cube is equal to 0. It means z is equal to 2 is a pole of order, m is equal to 3. Z equal to 2 అన్నాడు. సెంటర్ ఆరిజిన్ అండి, సెంటర్ ఆరిజిన్. Z equal to Z is equal to 3. That means this is 1, 2, this is 3. Okay, this is the circle. Okay, Z is equal to 2 inside. Okay, which is inside modulus of z is equal to, inside the circle modulus of z is equal to. So it is z equal to 2. First we have to calculate the residue, then apply the definition of residue. Okay. So first I am writing residue of the function f of z at z is equal to 2 is equal to 1 by 3 minus 1 factorial. This limit z tends to 2 d square by dz square of z minus 2 whole cube into f of z. F of z means you have to write that step. So I am writing this is equal to 1 by 2 factorial is 2. Limit z tends to 2. One second. Of z value. So here d square by dz square of z minus 2 whole cube into f of z value. That is z cube minus 3 divided by z minus 2 whole cube. Here z minus 2 whole cube will be cancelled. Now differentiate 2 times here. Limit z tends to 2. One time differentiation. That is 3z square. Again differentiate. That is equal to 3 by 2. Limit z tends to 2. That is 2z. So as z tends to 2, this value is 2. 2 into 3. This is 3 into 2. That is equal to 6. So write the integral value. Integral over c f of z dz is equal to 2 pi I of residue is 12 pi I. So which is the right option? 12 pi I, not 2 pi I. So option 2, yeah, 12 pi I is the right option. Now I'm taking another problem. The invariant points. This is a symbol by printer. Okay, we already did some problems to this. The it is a set question, understand? Set question. The invariant points of the transformation. Points of the transformation. The transformation W is equal to 2z minus 5 divided by z plus 4 is. We have options here. First option is 1 plus or minus 2i. Second option minus 1 plus or minus 2i. Third option plus or minus 2i. And the fourth option plus or minus i. Okay. Invariant points means fixed points. Fixed points means we have to equate the T of W or W is equal to Z. Okay. 1 plus or minus 2i. Okay, we'll see the problem. First, for invariant points, in bracket, I am writing fixed point, both are same. Fixed points. We have to equate z, w is equal to z. It is 2z minus 5 divided by z plus 4. Now solve the okay. We can solve the this equation. Okay. So we can write this as z square plus 4z is equal to 2z minus 5. That is z square plus 2z plus 5 is equal to 0. The factors stand now. So we can use the formula z equal to -2 plus or minus.
దీన్ని సింపుల్ గా మనము z స్క్వేర్ ప్లస్ 2z ప్లస్ 1 ప్లస్ 4 is equal to 0 అని రాసుకోవచ్చు సార్. z ప్లస్ 1 హోల్ స్క్వేర్ is equal to -4 అని రాయొచ్చు. z ప్లస్ 1 is equal to ప్లస్ ఆర్ మైనస్ 2i అని వస్తుంది. z is equal to -1 ప్లస్ ఆర్ మైనస్ 2i అని రాయొచ్చు సార్ డైరెక్ట్.
నాకు అర్థం కాలేదండి చెప్పింది
సార్. ఇప్పుడు అది ఆ ఫంక్షన్ ఉంది కదా సార్, z స్క్వేర్ ప్లస్ 2z ప్లస్ 1 ప్లస్ 4 అని రాసుకోవచ్చు సార్. ఫస్ట్
ఓకే 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 రైట్ రైట్ ఇలా రాసుకోండి. ఇది 4 ప్లస్ 1 ప్లస్ 4 అంటారా?
ఎస్ సార్, ఎస్.
1 ప్లస్ 4 రాసుకుంటే ఇక్కడ వరకు z ప్లస్ 1 హోల్ స్క్వేర్ అయ్యచ్చు. ఓకే ఓకే గుడ్ ఐడియా. Is up to this, from up to this we can write z plus 1 whole square plus 4 is equal to 0. అంతే కదండి? సో z plus 1 whole is equal to, we can write plus or minus 2i. So z is equal to -1 plus or minus 2i. Okay, good. Okay, so option 2 is the right option. Okay. Now లేదంటే మీరు ఫ్యాక్టరైజేషన్ చేయండి, మంచి మీరు చేయవచ్చు. నెక్స్ట్ ఐఎమ్ టేకింగ్ అనదర్ ప్రాబ్లం. Is a DL question. Of course, it is a TS set also. Simple question. I don't know whether we will discuss or not, but I am giving z divided by z minus 1 into z plus 3 whole square is. We have options here. First option, analytic function. Second option, entire function. Entire function. Third option, meromorphic function. Meromorphic function. And fourth option, integral function. Integral function అనేది మీనింగ్లెస్ అంటే కాబట్టి ఇది ఉండదు. అనలిటిక్ ఫంక్షన్ అవుతుందా? at first we are taking singularities. I am taking function. First of all, let the function f of z is equal to z by z minus 1 into z plus 3 whole square. Okay. So for singularities, the denominator singularities z minus 1 into z plus 3 whole square is equal to 0. That is z is equal to 1 comma minus 3 comma minus. This is a pole of order 1 and pole of order. Z equal to -3 is a pole of order 2. So except these 2 points, the function is analytic. So entire card analytic order chance లేదు, ఎందుకంటే z equal to 1 దగ్గర z equal to -3 దగ్గర analytic card. Next, entire అంటే ఏంటి? It is analytic at every way, but it is not analytic at every way except z equal to 1, z equal to -3, the function is not analytic. So it is analytic except for poles. Function, therefore, the function, simply I'm writing, therefore, f of z is analytic except for poles. Poles దగ్గర తప్ప మిగతా అన్ని చోట్ల అనలిటిక్ అవుతుంది. కాబట్టి that function is called meromorphic function. Therefore, f of z is meromorphic function. Okay. So already we discussed the meromorphic definition, a function which is analytic at everywhere except for its singularities or except for its poles. The function is called a meromorphic function. Okay. I am taking a problem from APTL. Of course, it is also GL problem of getting this problem. Yeah. The value of the complex integral, of course, is JL also. The value of the complex integral over C tan z dz. Where C is modulus of z is equal to 5 is. We have options here. First option 0, second option minus 4 pi I, third option minus 8 pi I, and fourth option is 8 pi I. So we have to see the singularities. First, I am taking the function f of z is tan z is in the form of sin z by cos z. For singularities, we have to take the denominator as 0. Singularities. It is cos z is equal to 0. Cos z is equal to 0 means z is equal to, it is a odd pi by 2. That is, you can write 2n plus 1 into pi by 2. This is pi by 2, 3 pi by 2, 5 pi by 2, like that. So, if you take z is equal to, if you take n is equal to 1, we get z is equal to plus or minus n equal to plus or minus 1. In this case, we get pi by 2. And n is equal to 2, we get 5 pi by 2, plus or minus. Okay. So, pi by 2, 5 pi by 2, these two are poles, which are inside or outside, we have to check. Pi by 2 means 22 by 14. Actually, circle ఏంటండి, center at origin, and radius is 5 units. This is the circle. 1, 2, 3, 4, 5. In minus and 1, 2, 3, 4, 5. Okay. First 22 by 4 means it is outside or inside. Inside ఏనండి 3 pi less or minus 1 second. Minus 5 pi by 2. 5 by 2 means 22 by 14. Means 11, 7, 11 means 5 point something. 5 point something. Here, next ఒక పని చేయండి. ఫస్ట్ n is equal to integers కదండి ఇక్కడ for n belongs to in I integers కాబట్టి n equal to నేను 0 తీసుకున్నాను అనుకోండి. ఫస్ట్ 0 కేసు తీసుకుంటే 5 by 2 వస్తుంది. 1 తీసుకున్నాను అనుకోండి 3 pi by 2 వస్తుంది. 5 by 2 3 pi by 2 ఈ 2 వాల్యూస్ చూద్దాం. 3 pi by 2. These two are poles. 5 by 2 means it is 22 by 4, 1.5. One second. Side dash of z. So that is equal to pi of z divided by side dash of z. So pi of z is cos z. Sorry, it is sin z numerator, and the derivative of cos z is minus sin z. This value become minus 1. Similarly, residue of f of z at z equal to 3 pi by 2. ఇక్కడ రెసిడ్యూ ఫైండ్ అవుట్ సేమ్ వస్తుంది కదా. pi of z divided by side dash of z. That is nothing but sin z by constant value వస్తుంది. కాన్స్టెంట్ వాల్యూకు మీరు లిమిట్ అప్లై చేస్తే మైనస్ వస్తుంది. అంటే 4 పాయింట్స్ రెసిడ్యూస్ మైనస్ వస్తాయండి. 5 by 2 దగ్గర -1, -5 by 2 దగ్గర -1, 3 pi by 2 దగ్గర -1, -3 pi by 2 దగ్గర కూడా -1 వస్తుంది. Therefore, integral value we have to calculate. F of z dz is equal to 2 pi I. First term -1, -1, -1, -1. Sum of residues. We are writing this is sum of residues. So sum of residues are -4 and so 2 pi I of -1, -1, -1, -1. This is -8 pi I. So residue, the integral value is -8 pi I. Okay. Now I am taking another problem. Taking another problem. The value of the complex integral over c z cube into e to the power of 1 by z square dz, where c modulus of z is equal to 1 is option 1 0, option 2 pi I, option 3 2 pi I. This is pi I. Option 4 is pi I by 2. Okay. Now first take the function f of z is equal to Z cube into e to the power of 1 by Z square. So we can write this as Z cube of, we can expand e to the power of Z, 1 by Z is 1 by Z square. That is 1 plus 1 by Z square by 1 factorial plus 1 by Z square whole square by 2 factorial plus 1 by Z square whole cube by 3 factorial plus and so. This is the expansion. That is nothing but Z cube of 1 plus Z square plus 1 by 2 Z power 4 plus 1 by 6 Z power 6 plus and so. So now multiply with the Z cube. So we get a Z cube, that is Z first term. This is 1 by 2Z plus 1 by 6 Z cube plus and so. And clearly we can observe up to this analytic part. And remaining all the terms have Z terms in the denominator. So it is principal part. So Z is equal to 0 is a pole, is a singularity, okay, essential singularity, and which is inside the circle. Circle ante C is the circle, modulus of Z is equal to 1 means it is a circle of center origin and radius 1 unit. Okay. So Z equal to 0 is a singularity inside C, modulus of Z is equal to 1. So we can calculate the residue of the function f of Z at Z is equal to 0. That is equal to basic definition coefficient of Z minus 0 whole to the power of minus in f of Z. In the expansion of f of Z. That is Z power Z minus 0 whole power minus 1 means Z power minus 1. That is 1 by Z coefficient is 1 by 2. This is equal to 1 by 2. Residue will be 1 by 2, but we have to calculate the integral value. Therefore, integral over C f of Z dz is equal to, by definition of residue, 2 pi I of residue of the function. That is equal to pi I. Okay. This is the right option. So pi I is the second option, is the right option. Okay. The next class we will see the problems on Lorentz expansion and Taylor series expansion, and also some problems on integral evaluation of integrals, improper integrals by using complex analysis, and we will discuss Roche's theorem and argument theorem in the next classes. We can take 3 or 4 classes. If you have question, you can ask. Yeah.
Good evening, sir.
Madam, good evening.
Sir, this one problem 5z minus 2, that problem we have, sir. There we took 2 residues, sir. How come